Lesson 22. Today we're starting Unit 4, conics. Now, conics are defined by conics given the fact that every single one of these conics is made by a cone cut in a specific way. Okay, you'll notice the circle is made by cutting in a horizontal pattern that is parallel to the base of the cone. Okay, the ellipse will be cut in a diagonal fashion, forcing us not to pass through the edge of the cone down here. Okay, that, as you notice, will be a parabola. Now the last one, hyperbola, this is not a full visual of the hyperbola. With the full visual of the hyperbola, what we'd actually see is a secondary cone up here. Okay, and this plane, there's a plane cutting through all these, a plane cutting through for the circle, a plane cutting through the ellipse, a plane cutting through for the parabola. For the hyperbola, when the plane cuts through this one, it's also going to cut through the secondary cone that would be up here. Okay, so what we're going to do is all of these conics come from this visual image. They also come from a geometric definition. Okay, so when you're looking at these things, you want to keep in mind that there is a graphical representation, there is a geometrical representation, there's the understanding of how they can be developed representation, and then there's the algebraic representation. Okay, so what we're going to do is we're going to start defining what these things really are, and the way that we're going to define them, we're going to then develop an equation, an algebraic equation based on that. So a parabola is specifically a set of points in a plane that are equidistant from a fixed line. That's what we're going to call the directrix. Okay, again, a fixed line, that's a directrix. And the focus, which is a fixed point. So, down here in number 4, and I'm going to actually draw on a separate piece of paper, it says draw an image below that identifies the axis of symmetry, the directrix, the focus, the vertex of the parabola. So, I'm going to create a point and a line. And again, the definition of a parabola is specifically all the points that are equidistant from this point to this line. Now, what I'm going to do is I'm going to draw up to that point a perpendicular line. Okay, so again, notice that that's a perpendicular line right there. Halfway between, there's a point. Okay, now this point is the first point that I'm going to draw on that parabola. This point, we're actually going to label the vertex. Okay, it is again the point halfway between this line called the directrix and this point called the focus. Now every single point on the parabola, which we've seen before, every single point on the parabola is equidistant from the focus, okay, to this line. So if I were to draw this here, you'll notice, or at least you should be able to notice if I drew it correctly, that this line here, okay, and this line here are the same length. And again, if I do it somewhere else, let's do it way up here, okay, that line there should be equidistant to that line there, okay, and that's the point. So it's every perpendicular line up to, okay, this parabola, this graph, should be equidistant. So this is clearly not drawn to scale. Okay, I did not draw that accurately enough, but that's the idea. Okay, now we have the focus, the vertex, the directrix. It says identify the axis of symmetry and those three pieces. The axis of symmetry is obviously the line that passes through the vertex, the focus, and the directrix. This is my line of symmetry. Why? Because if I were to fold this thing on top of itself, that would be the line. Okay, that everything on this side is exactly the same as everything on this side. Okay, so this is again the geometric definition of a parabola. Now notice this is the same as an equation that would be a quadratic. Notice now the difference between a quadratic and a parabola. A parabola is the physical definition of the distance between the focus and the directrix is equidistant, and that set of points creates the parabola. Whereas with a quadratic, that is specifically the ax squared plus bx plus c. It is the equation defined by this. Miraculously enough, this equation and this definition geometrically are actually the same thing. Okay, so In terms of the standard forms of an equation of a parabola, okay, there's a number of different ways we could see it. Now, this is for number 5, and I should be going through this. The problem with number 5 is it doesn't work all the time. You'll notice for number 5, it says the standard forms of the equation of parabola with a vertex at the origin. Okay, so this only works if we're playing with a parabola that's centered at 0, 0, that has a vertex at 0, 0. So, all of the equations for this, okay, will be x squared is equal to 4 times p times y. Okay, now notice the difference between this and this. Okay, if I let this equal to y, then I have y is equal to something in terms of x squared. Over here, I have 4 times p times y is equal to x squared. And then the question would be is, what is that p value? Okay, why would that be important at all? Well, it actually works out that if this thing is centered at the origin, okay, again, this is centered at the origin, meaning that my vertex is equal to 0, 0, okay, the p value actually determines the focus and the directrix. Okay, it actually tells me how drastically this thing has been. This thing is far away from the focus of the directrix. Okay, so again, it's the vertex that's centered at the origin. So I'd have something that looks like this. There's that point. Okay, and then it would do something like this. Clearly, because it's y is equal to some sort of x squared facing up. If it was, and let me rewrite this one down here, y squared is equal to 4p times x, which way would this look? This one would look facing sideways. Okay, and again, this isn't any different than what we would have if we were looking at x equals y squared. Okay, the only change is the fact that this p is here. Okay, well, the focus and the directrix come from this value of p. Okay, the focus has to sit directly above the vertex, the origin. Okay, in this particular situation, it sits directly above. How much does it sit directly above? It sits that value of p. Okay, so the focus then is going to be 0, comma p. I'm going to add p to the y value. It's sitting with the y value. That's what's going to change. Okay, the directrix is going to be a line that sits down here. Okay, again, we have the point, we have the directrix, and then the parabola sits like this, trying to rotate around that focus. So then when I draw this, this line has to be down here, the focus has to be here, okay, and then this line is going to be what? Well, how can I make sure that the focus is equidistant to the vertex in comparison to the directrix? Well, the only way that's going to work is if I let it be a y equals, and it's got to be a negative p value. Okay, so this is assuming that we have centered at the origin, and more importantly, we have a directrix or an axis of symmetry. I should go with axis of symmetry. Okay, the axis of symmetry is the y-axis. Okay, so that fills in 5 for the equation right here, the vertex, the focus, and the directrix. Okay, what do you think this one's going to be like? Well, the focus has to sit over here now, and the directrix should sit over here. And this is for a graph that has the axis of symmetry, the x-axis. Okay, so I'm going to go ahead and write this down. The axis of symmetry is the x-axis. Okay, this is still centered at the origin. And my vertex is still 0, 0. Okay, the focus, however, still compares to that value of p, but this time it's shifting in the x direction. So my focus will actually be p comma 0. Okay, and lastly, my directrix will actually be, and I shouldn't put equal signs here, not at y equals anymore, it's now x equals, because it's a vertical line. X equals what number? Well, the negative p value. Okay, and that concludes all of your parabola information when it's set at the origin, when the vertex is specifically sitting on the origin. Okay, so let's go ahead and take a look at 6 and talk about finding the focus, the directrix, and all that information in terms of the parabola. So, example number 6 says find the focus and the directrix. Okay, if I was given y is equal to a negative 1/2 x squared. Now, for me to be able to play with this, what I want to do is I want to see it as x squared is equal to something. So I'm going to go ahead and make it look like negative 2y. Okay, multiplying both sides by a negative 2. We'll eliminate this and this, and I'll have this form. Now I'm going to go ahead and pull this page back up so you can see it one more time. X squared is equal to 4py. That's the form I want this equation in. I want this equation to look like x squared is equal to 4 times the p-value times y. So the question is, what p-value would I have to have in order to make 4 times that p equal to a negative 2? Well, negative 2 has to be equal to 4 times p. I can divide both sides by 4 and get p has to be equal to a negative 1/2. Okay, so that verifies that this x squared should be actually equal to a 4 times a negative 1/2 times y. My p-value is a negative 1/2. If my p-value is a negative 1/2, I have y equals x squared in some way. That means that my parabola will be facing vertical or down, one or the other. And notice, since it's negative, it will obviously be facing down. Okay, it'll be this one down here in some way. Where's my focus? Well, my focus is going to be specifically at the point that is going down here, 0, negative 1/2. Okay, it is exactly equal to the p-value. Again, it's 0, comma p every single time. The directrix is going to be y is equal to, because y should go like this. Okay, here's my focus. It should be opposite side of the vertex, and it should be a y equals line. What should it be equal to? A negative of that p-value. So there's my directrix and my focus. Okay, if I were to ask you to sketch this graph, you could very easily just go ahead and, this is my vertex. This point here would be 0, comma negative 1/2, and to emphasize, this would be a y equals 1/2, and that would be it. Okay, that's all we would need to verify that that's the parabola. Okay, let's look at 6b, and then we'll wrap up this video. 6b is x is equal to 2y squared. Again, we want it to be in the form of the squared term equal to 4p times the other term. So this is what I'm looking for. I need to rewrite this so that it looks like this. Well, I'm going to have y squared is then equal to 1/2 x, and I want this 1/2 to be equal to 4p. What does that mean p has to be? Again, I can set 1/2 equal to 4p, and then I can go ahead and divide both sides by 4 and get 1/8. Therefore, y squared is equal to 4 times 1/8 x. Okay, let me move this up. So my p-value is equal to 1/8. What does that tell me about my focus and my directrix? Okay, well, the directrix, since this is a y squared term, I know that this thing is facing this way or this way. Okay, it's this one or this one. And since it's a positive p-value, it's going to be this one. So that means my focus is going to be a x direction change by a 1/8 and a 0. And my directrix is going to be in the opposite direction, a negative, sorry, it should be an x equals now, a negative 1/8. And that completes example number 6. Let's go ahead and finish up 7. We might as well. We've got the time here. It says find the equation of a parabola in standard form provided the information. I have a vertex at the origin, okay, and a focus at negative 2, comma 0. Well, I'm going to go ahead and draw this image. I have 0, 0, and the focus is at negative 2, so I go 1, 2. There's my focus. My vertex is here, and the parabola always rotates around that. So I know that this thing should be this. Well, if that's the case, I know my y is the thing that has to be squared, so it's y squared 4px. Okay, and the last thing I need to worry about is what is p going to be? Well, p is the value that's inside the focus. So this is y squared is equal to 4 times a negative 2 times x. Y squared should be equal to a negative 8x. And this is the general, or the equation for the parabola with this information. Okay, and again, I always go to the sketch. It makes my life easier.